Hello viewers, in today's class we are going to discuss a fundamental problem from limits involving greatest integer function, right? And here we have to find this limit, that is limit x tends to half and greatest integer of 2x minus 1, right? So here what we will do, we'll first find the right hand limit and then the left hand limit, and then we will see whether the limit of this function when x tends to half exists or not, right? So here we can solve this problem by two methods, right? But here in this lecture we will discuss only the first method, right? And the method is by method of substitution. So here let us first take t is equal to 2x minus 1, right? So here we are making this substitution, that is t is equal to 2x minus 1, and see here x tends to half, right? So when x tends to half, then we can easily see from this relation that t tends to 2 times half minus 1. So we have t tends to 1 minus 1, that is t tends to 0, right? So now we can transform this limit to limit t tends to 0. For x tends to half, we can now write t tends to 0, and here we have the greatest integer of t, right? So now this limit is reduced to this one. So now let us write this limit as L, right? Okay, so now here we have t tends to 0 and greatest integer of t. So now what we will do, we'll take t is equal to 0 minus h for the left hand limit, right? So first we will find out the left hand limit, and for left hand limit we'll take t is equal to 0 minus h, where h is a very small quantity which lies between 0 and 1, right? So when t tends to 0, obviously h tends to 0, right? So now the left hand limit it can be written as limit t tends to 0 minus, and here we have greatest integer of t. So now we can write it as limit h tends to 0, and for t we can write 0 minus h, right? So we have here 0 minus h. So this can be written as limit h tends to 0, and we have greatest integer of minus h, right? Okay, so now here we cannot directly substitute h is equal to 0, right? So what we will do, we'll take help of this relation. Here h is a positive quantity and h is a very small quantity, right? And it lies between 0 and 1. So what we will do, if we multiply both sides throughout this inequality by minus 1, what we will get 0, and the direction of the inequalities get reversed. So we have minus h here, and here we have minus 1, right? And this inequality can be written as minus 1, here we have minus h, and here we have 0, right? So now from this inequality we conclude that minus h lies between minus 1 and 0, and from the definition of greatest integer function, the value of greatest integer of minus h should be equal to minus 1, right? Because minus h lies between minus 1 and 0. So here we can now write limit h tends to 0, and for this term we have here minus 1, so this is equal to minus 1, right? So the left hand limit of this function when x tends to half, we have converted this problem into the variable t. So now the left hand limit is equal to minus 1. So now let us find out the right hand limit. So the right hand limit, it can be given as limit t tends to 0 plus, and here we have greatest integer of t, right? And again will take t is equal to 0 plus h, right? So this time we have to take 0 plus h because all the values of t which are approaching towards 0 from the right of 0 are greater than 0, right? And h lies between 0 and 1 because h is a very small quantity here, and we have this inequality, right? So when t tends to 0 here, h tends to 0, right? So the right hand limit can be written as limit, and we have now h tends to 0, and for greatest integer of t we can now write here 0 plus h. So this is limit h tends to 0, and we have greatest integer of h, and see here h lies between 0 and 1. So from the definition of greatest integer function, the value of greatest integer of h should be equal to 0, right? So here we have limit h tends to 0, and here we have 0, and this is equal to 0, right? So we see that the left hand limit is equal to minus 1, and the right hand limit is equal to 0, and these two limits are not equal, right? And from the definition of limit of a function, we know that if the left hand limit exists and finite, and the right hand limit also exists and finite, and both the limits are equal, then we can say that the limit of the function exists. And here minus 1 is not equal to 0, so we conclude that the limit, this limit does not exist, right?